Very good morning to everyone. As part of our Python learning journey, we are going towards our next step. Right. So in the last session, what we learned is using a GUI, we try to give input to a CAN signal right now. So we use a track bar for that, and then we wrote a necessary event procedure which links the track bar event to the CAN signal. Right. Up to that we have achieved. But in real time, we have to react to output, CAN signal output. Sometimes some ECUs are sending some outputs. Based on that output, in the car, in real car, we used to do different behavior. For example, turning on a telltale, displaying a warning message, moving a gauge needles to a particular position. Like that, in real time, the ECUs in the car will do a reactions, right? So we have to, when we develop, when we prototype vehicle network in software, we have to mimic those reactions. Today, in today's session, we will learn how to create such a output behavior using Python GUI. Right. We already know that we are using Tkinter for developing GUI for our simulation, press bus simulation right now. So in order to mimic real-time issue behavior, output controls are made in GUI. So for that, we can make similar output reaction controls in the GUI. Then we link with the CAN signal output to those output control and can create and can mimic the real-time behavior of that ECU right now. So the Kinter, we have function to achieve it. The Kinter has different functions to achieve the real-time behavior of the ECU. There are functions to show the image and then to draw the shape on the image. Like that we have, we'll study them one by one. Among them, the canvas is the one feature that we have in Kinter. Using that, you can bring the image to the GUI and then you can draw shapes on the GUI. The canvas is a frame, so within that frame, we used to draw images and shapes in Kinter. Okay, now to create canvas in Kinter, you have to follow the following syntax. So your canvas object name is equivalent to canvas is a library function that you have to call. Then you have to say in which screen you are going to create a canvas, because the canvas is a frame. The frame should be embedded in a GUI. That GUI we have to specify the GUI object, and then the width of the canvas and then height of the canvas, the dimension of the canvas we have to provide right now. This is the first step to create the frames in the GUI, right? Okay. After creating the frame, we have to bring the necessary images to the frame now. For that, Kinter has functions like ImageTk.PhotoImage. This function will fetch an image from the hard disk of the computer and then will convert that into an image object. So that is the task of that function. So the image.tk.PhotoImage is the function name. Then you have to pass the path, the relative or absolute path of your image file. Then after creating the image object, we have to embed that image into the canvas frame. For that, we have the canvas.create image function. This function will embed the image that you created from a file to the canvas. So for that, you have to provide the coordinates to where you have to locate that image in the canvas, and then the alignment, there are different alignment, top left, top right, like that. Here they use a compass point, that northwest, northeast, middle, center, like left, right, something like that. So you have to provide your compass point for to align your image inside the canvas frame. Finally, you have to provide your image object that you are going to display in that frame. Right. So this is the function to create an image in a canvas. After doing it, not only displaying the images, sometimes we have to create some dynamic behavior on the image, like moving a needle, displaying a telltale, displaying a warning message, those stuff. For that, we have different shape creating function like create line, create oval, like that we have. Using them, we can create different shapes on the image, right? So among them, we are going to learn about two things like create line and then create circle. These are the two functions, shape function that we are going to use in our today implementation, right? So in order to create a line, again, you have to provide your starting point and ending point coordinates, right? Between two coordinates, we are going to draw a line. No, you have to provide that, and then you have to provide necessary options like whether you want to fill a color to it. If that is the case, what is the color? And then do you need a arrow in the beginning or end of your line? And how the finish, how you want to look it, like is it a smooth or rough finish? Then we have a thickness of your line, that is termed as width here. So you can provide here. I have given an example values for those options, right? Similar way, when you want to create a circle, you have to call a function create oval, and because there is no inbuilt function called create circle in Kinter, we have to use create oval to create a circle, right? So you have to provide, when you create a circle, you have to provide your x dot and y dot and xn and yn, which is nothing but your radius starting point and radius ending point. Then respective options. So here are the options like fill. Here I have used an option fill to red because I want to create a red circle in mid of my meter image. That's why I go for red here, right? These are the things that we have to know before entering into today's session, right? So let us go for implementation, right? So for that, I have a program. So as we are going to mimic the instrument cluster module today, so I'm going to work on that file now. So here is a program that I am going to demonstrate here. These things are old thing that I already gave in the enough introduction. But today I developed a function called ICM dashboard. This function is going to draw a meter in my GUI, and then it used to move the needle on it, right? Based on the packet received from other module, because the vehicle speed is the message which is generated by body control module in our project, and the ICM is the one which is going to display the speed in a gauge, right? So the for ICM, it is the this vehicle speed is an input, right? It should decode it and how to take the vehicle speed signal. Then it should use a vehicle speed signal that is fetched from that packet to move the needle. Okay, now for that, to create a dashboard first, I make the root window to global. Maybe because I'm going to use this window in other threads. I'm going to access them in other threads. So I make the root object is nothing but the parent window. I make that to global. After making it, I just create a window in it and I specify the geometry of that one, dimension of that one. After doing it, I create a size dimension for canvas. The canvas is an image frame, no? For that, I specify its width and height and other stuff. After doing it, I fetch the image called meter.png that I have in my hard disk, and I create an image object. Right. Let me show the image what it has in that one. So it is here called image meter. So let me open the meter. This is my meter. My meter has a display to that is speedo and tacho gauges in it and respective ICC buttons and other stuff. Right. So I'm going to use this image to mimic ICM module in my software prototype. Right. So for that, I read that image here. I read that image here and create an image object. After creating it, I create a TK image, which is nothing but where I am just converting that to fit the requirement of TK. So that for that, the function used is ImageTk.PhotoImage. Whatever the image object that I created, no, I pass to this and I get the output as that is processed image from the TK. So after doing it, I create a variable called canvas. This is just like a object that I'm going to use locally. I make it global because I may access this canvas in other threads. That's why I convert that into global. After converting it to global, I create a frame first. So my frame is going to be, it is, go, it, we are, I'm going to create a frame in the root window, which has a width and a size height as I specified here. I believe probably where I have created here. No, with that dimension, I create an image frame. Brilliant. After creating that frame, I pack that frame to main window. After packing it, I create an image inside the frame, image frame at the coordinates 20, 20 with the anchor. That means with the alignment northwest, which is nothing but left top right now. That is what the northwest is. That is the one now. The left top with the image object that I created. The processed image from this one is given so that the image will appear in the GUI. Brilliant. So I have a meter image. After doing it, I create two global variable called X and Y. They are coordinate of center of my speedo gauge meter. Why I make them global? Because I'm going to use them in other threads across the threads. That's why I make them global. After doing it, I give the X to 560 and Y to 260. Why I am giving this value? Why don't it can be some other value? Why I specify this one? Why I have hard coded? Because in my image that I have for meter right now, this coordinate, the center of this meter is coming under the coordinates x 560 and 260. So if you have a different meter image, according to that you have to update, right? It is not fixed one. So it will vary, depends on the meter image that you have. In order to locate the center, I to use this coordinate, right? After doing it from the center of the meter, I have to draw the line to place the needle in different angles because 0 is in one angle, 10 is in another angle, 20 is in another angle. Like that, I have different angles here. No, so according to that different values, I have to update my line angle. So initially, when the vehicle speed is 0, the line should drawn from center of the meter to 0. When it is 30 kilometer per hour, it should come here right now. So like that, the angle of the line that I am drawing from the middle of the gauge will vary, depends on my vehicle speed. That's why I use a calculation to find out the end point. So my center point, the starting point is fixed. It is center of the meter. My ending point, sometime it will be the coordinate of 0, sometime it will be coordinate of 30, sometime it will be coordinate of 60, sometime it will be coordinate of the 90. Like that, I used to have different coordinate, depends on the speed right now. So that's why there is a formula to find out the end point of an angular line. So I have to specify my y line, that is the starting point of my y plus, and then I am multiplying this 115 is nothing but my needle size. The needle will also have a length now. I am giving 115 points to for my needle to that I am using it as a needle size. Then I use a function math dot sign of math within that math dot radian of 87. What is this 87 or 87 or it can be a 90, because when I give 90 as the angle, only then I can draw a line from center to 0 right now. So actually see, this is plus 90. See, this is 0, 90, 180, minus 9, minus 90, and minus 180, like that it used to have. No, we used to have those who studied vector mathematics, they know about it, like how these lines are drawn. Right. So I have to give a 87 as a angle in order to get my end y and end x coordinate, which is pointing this 0 in this image. Right. For that, I give that one initially. After that, after doing it, after finding my end x and end y, I calculate, I have to draw, I'm drawing two circles. One is a red one, another one is a gray one. So, which is nothing but in this meter that I have, no, I think it is, I am running that one. In this meter, I have the center point, right? In that center point, I want to have the needle head, right? For that, I initially have a red circle and then a gray circle, right? So that I am drawing. So my red circle has 20 points as a radius, and my gray circle has 10 points as radius, right? I create those two circles. After doing it, I create a line. From where to where? From the center of the image, center of the gauge to the 0 point. So for that, I am drawing the line which is having an arrow. So I mimic a needle on the image now, right? Okay, brilliant. After doing it, it is pointing 0. With that, I am waiting for user input. That's all. This is the function that I have created for to display the ICM dashboard. Okay, brilliant. Okay, now where to execute, where to call this one in the main, right? We have a main function here, no? So if I call this is the main, if I call that ICM dashboard in the beginning, my transmit message and on message, both of them will not work. Why? It is having a blocking statement. The blocking statement is nothing but it is waiting here for user input, right? So after doing those tasks, it's waiting for the user input. If I run it in the main thread, what will happen? It will block the other threads like the transmit message and on message, nothing will work. That's why what I do, I run it in a separate thread. So threading dot thread, I call this task in a separate thread. I am running it separately. Okay, no. So in the main, transmit messages and on message are same as we do before. The transmit message will transmit the message, and then they will draw the dashboard in the GUI screen. After that, they will do a on message. The on message routine, the default skeleton of the on message routine is same, but in the previous implementation, we just there is a callback function. No, when there is a message, we used to call the callback, right? That callback used to simply print the message that it received, but we are not going to do that one now. Instead, we are going to move the needle of the meter that we have drawn. Right. So for that, here is a callback. This callbacks, whatever the variables that I created in the dashboard function, no, I made some of them global. I bring those globals here because I am going to interact this the dashboard routine and then the callback routine. They are going to share some variable like root, canvas, and y, and x, and vs previous, x, y, line ID, like that. These variables are reused here, otherwise shared between the things. Then after that, the message that we receive in the via RabbitMQ, no, to the ICM module, it will be in the form of text. So we convert that one into dictionary using this option. JSON.loads will convert that into dictionary. After converting it to dictionary, we are getting the vehicle speed here. So to get that, we have to say data, the parent dictionary, and then the child dictionary key. So when we specify that, we will get the vehicle speed. As we are going to use a calculation, we convert them into integer so that my vehicle speed integer will be given. Then we are doing a calculation of angle. So how the calculation of angle has been done here, we are multiplying our incoming vehicle speed with the 1.33, and then we are also adding, right? We are also adding 85 to it. Why we are doing it? Right. 85, we are adding it. Why we are doing it? So this structure is something like y equivalent to mx plus c, that format. Right. Always the angle will not exceed 360. We are using a modulo here. Okay, brilliant. Those things are great. Then how I achieved, how can I say the value is, m value is 1.33? Why it is not something else? Right. Again, why I have added 85 here? Why I don't add something else? These things are in our mind, no. For that, we have a explanation. See, when I give the angle 85, only then 85, which is closer to 90, only then it point 0. If I give 0, it is pointing like 1, that is 360. So what I have to do, I have to do a shift of angle. I have to shift the angle to 90 degree, right? No, minus 90 degree. Here it should come. For that only, I am adding approximately 90, with in order to fix to my GUI or my image, I am adding 85. It's okay. So when I do that, I am getting my needle will point here. So this offset is added in order to compensate this angle difference, because if I have a 0 vehicle speed, it will point here. When I have a 90 vehicle speed, it will point the 0, right? To map zeros vehicle speed to 0 angle, we are doing this offset. Okay, that is okay. Then how I am calculating this 1.33? See, when I give the angle 0, 30, 60, when I give a different angle, I checked, I placed an angle, and then I placed the needle to 0, I noted down the angle. I placed the needle to 30, I noted down the angle. I placed the needle to 60, I noted down the angle required to do that. So I made a homework. After making the homework, I plotted the vehicle speed versus the angle. So different vehicle speed, what is the angle that that is required to produce that vehicle speed deflection in the gauge, right? No, for that I have this Excel sheet. Here we have speed and then respective angle that is required to required, or that we have to use to make it to point that respective vehicle speed. So it's nothing but when I give angle 38, I am able to point my speed of gauge to 30 kilometer per hour. So that is the thing. So like that, I have a different vehicle speed here and different angles here. So now we have a interpolation of values, right? Vehicle speed versus angle. Then we have in order to find out the slope, because this is y equal to mx plus c, no? In order to find out the slope, we need at least 2 points. We are using, this is x1, x1, y1, x2, y2. To find out the slope, y1 minus y2 minus y1 divided by x2 minus x1. That will give you the slope. Then that value is, in our case, when I use these values, I am getting 1.33 as a value. I use that value in my calculation. 1.33, 1.33, and the vehicle speed, and then offset value. So I find out a processed angle. Then that angle is given to given to the formula, which is finding the angular endpoint, right? So we are finding end x and end y. After finding them, I have to move the needle. No, when I try to move the needle, initially assume my vehicle speed is 0. In that time, my vs previous value also 0. both are same. As there is the same, it will simply come and store the previous value as current vehicle speed, which is 0. Okay, brilliant. It won't do anything. Now I am changing the vehicle speed. When I change the vehicle speed current values assume some 60. So in that time, they will come here and then they will check whether my previous vehicle speed is not equivalent to current vehicle speed. Previous vehicle speed is 0, current vehicle is 60. So as it is not equal, they delete the needle which is pointing from center of the gauge to the 0, and they will delete it, and then they will draw a new line. Right. In order to delete that one, we need a pointer. Right. We cannot simply delete them. We need a reference. Only then we can do that. No, that's why while creating a line in the dashboard itself, we use a pointer here, line ID. No, using that line ID, I am deleting it. I am deleting it. Right. So that the needle which is pointing the 0 is deleted now. Now we have to draw a needle which is pointing 60. The 60 is no, it has its own angle. When you see the image, 60 is not having the same angle as that of 0. It is somehow 90-degree shift, right? So I have to I have to calculate that angle. To calculate that angle and only we have this formula. Right now at the end of the thing, we will find out the angle for 60-kilometer vehicle speed, then their respective coordinates we have. Then I use them in the create line function to create the needle, which is pointing from center of the gauge to 60 kilometer per hour. So the xy coordinate, which is nothing but center of the gauge, and then end y, which is nothing but the point at the 60 kilometer per hour in the image. Then we are filling that line with the red, which is nothing but we are setting the color of the line with the red. And then we are also including an arrow at the end. We are doing a smooth finishing. The thickness of the line is 5 points. After doing it, we assign the current vehicle speed, which is 60, to the VS previous. Right now, next time there is no change in the vehicle speed, nothing will happen. It will still stay there in that needle position only. If there is a change in the vehicle speed, then they will delete the current needle which is pointing 60. Then they will draw a new needle which is pointing towards, maybe the new value is 90. They will go there. So like that it used to work. Right. That's all, team. I have explained the code now. Let us see the demonstration now. For that, we have our old vehicle speed transmitting function, which is nothing but a GUI with a trackball, right? So that is here, it is pointing 0. Then we have, let me close it and rerun that. Right. Now I am running my IC module. Right. I have a meter here in my GUI. The meter is pointing 0. The vehicle speed is 0. The gauge is also showing 0. Now I slowly moving it to 30 kilometer per hour. When I set it to 30, it is pointing 30 kilometer per hour. When I move that to 60, interesting. It is pointing the 60. This is kilometer scale. This is mile scale actually. It is pointing 60 kilometer. That's all. So like that, so now we have created a software prototype of IGM module, which accepts the messages from outside world, which is nothing but a different ECU, BCM. Then it decode that and fetch the signal and use the signal to display, to show that in the GUI. So this is the real time. It will work in the same way. There will be a canvas and then real ECU module. Here everything is software. That's all, team. Today I explain you how to create a prototype of ECU, and then how to react to the signal input from the other ECU using this simulation. Okay, so that's all for today. Let me catch you with more detail in upcoming session. Thank you. Thank you for watching.